Thank you very much for having me here in this wonderful place. My name is Balint Vanek. I'm from Hungary, representing Ventus-Tech, a small company from Hungary. And I'm going to be talking about how we actually did a survey of the famous Chain Bridge in Budapest, which is kind of a national heritage site for us. So you can see that even on the 200 forint coin, it is actually the thing just right here. So it's every Hungarian is very proud of this monument, and I'm just gonna have a quick video what I'm gonna be explaining in the next 20 to 25 minutes. What you see here is the location. So you see it's in the middle of Budapest. I will explain some of the technical details, how to get flight permission, and what were the challenges. Then, of course, we started our survey with having a LiDAR flight, and you could see the beautiful YellowScan software and also the equipment what we used. We also augmented the LiDAR scan with some under-the-water bathymetric survey from a multi-beam sonar. Then we also captured some other LiDAR data and photogrammetry, and then we actually vectorized the whole thing. And based on all these vector features, we built a 3D model what can be brought into the BIM, Building Information Management Framework. And after that, we showed it to our customer. Actually, we didn't get paid for this job. We just did it as a promo to showcase to them that maybe next time, before such a project starts, it would be a nice thing to build such a 3D model of the entire National Heritage Site. So I promise I'm going to be talking about all these steps, what you see here on the video. What you just see that like data capture, data processing, and after that, how to actually vectorize and 3D model the entire structure. You can see the level of detail that like it was not a small task to overtake. Even the ornaments and everything on the bridge have to be captured. And at the end, like, we made one first video, which was so photorealistic that I have to tell the guys doing the video that, yeah, please tune down a little bit, because everyone would think that it's just a guy flying a $500 drone capturing the building or the bridge itself. So we made a little more cartoon or animation-like. But you can see the level of detail that we captured all these details thanks to different, as I said, different combination of sensors and a very extensive modeling process at the end. And it was kind of a joint work between Ventus-Tech, company I represent, and BIMFRA, another company in Hungary. So luckily, we also, after we did the project, we also got some feedback from the industry and from some media that we did actually a nice work, and I'm really happy to also advertise our work here. So just a little background about our company. We started 7 years ago with photogrammetry. We are mostly focusing on let's say, linear infrastructure, mostly roads and railways, roughly 1,000 kilometers per year from the design, construction, and finishing stage. And I think we are kind of partners for YellowScan for 4 years by now, and we are very happy to work together with the YellowScan team. So it's always a pleasure to talk technically and also come here and enjoy the nice atmosphere. So about the location, I told you that, or you can imagine that, like, okay, flying inside the city is difficult, but actually this site is very, very tricky, because the Prime Minister and the President's office is here, roughly 200 meters from one end of the bridge. The Ministry of Interior Affairs is also like kind of 150 meters on the other side, and the Hungarian Parliament is roughly 500 meters from here. So my colleague just listed all the paperwork what we have to get. So from police to Hungarian airspace and everything. Probably it was 11 different papers what we have to get from different stakeholders. But we managed to do it. And what was also interesting, or what we wanted to do, is not just only have a drone-based survey, but also survey the underside of the structure. So we actually built a custom boat with photogrammetry equipment to be able to capture all the different sides of the boat or the bridge itself. What was also tricky, that, like, of course we got the permission to survey it when they already started putting some structure for the construction underneath it. So we have to go with the boat as quick as possible to survey the understructure. And then with the multicopter, we could go when we have all the permissions. Of course, it takes 30 days in Hungary to get all the paperwork, so it was a bit tricky. And just a little background why we actually got into this situation. So the company who was doing the, let's say, anti-mine detection inside the river itself got this multi-beam sensor recently, and they were able to capture the large amount of point cloud, but they were not able to process or do anything with it. So they just came to us to ask, okay, could you help a little bit? And a lot of the tools what we have for LiDAR were applicable also for this bathymetric data set. And as I said, it was kind of a pro bono work to just show our deep love to this bridge. And yeah, some of the equipment what we used, of course, drones, DJI 600 with the photo equipment, with, of course, YellowScan LiDAR. This is kind of the multi-beam what was put on another boat. And this is the custom boat what we made. Notice that actually it has 2 GPS antennas and 2 cameras mounted on it. So it's a quite unusual setup, and we had to develop a lot of custom software and custom tailoring to handle it. So you have heard about the YellowScan products today already. We were using all the tools available. So planning the flight and then post-processing it with the AirPlanning software and Cloud Station. I think strip adjustment is very important, and we use strip adjustment extensively. And of course, because we had a TLS, like terrestrial laser scanning, we were also able to align things. And that's something what I would also recommend for the YellowScan team, to kind of have not just only Z directional, but X and Y directional alignment to be able to better match TLS scans. And of course, we have a special projection system which requires a lot of massaging of the data to put it into this Hungarian system. A little background about the boat, what we actually developed. So it looks like as something what we were tailor making, and it is actually a tailor-made boat. And because of that, the workflow is not that developed. What we were saying is that let's have 2 cameras pointing upwards in kind of a cross-pattern situation. We have a flight control computer which is providing inertial data, and we have the 2 GPS antennas there. We were using some open source software, the RTK lib, to post-process the GPS data, and then kind of a manual work to align all the data together. So what is interesting to see here is that, like, underneath the bridge, you have either data loss because of loss of GPS signal or very bad quality GPS data. So we had to kind of align a lot of the data to be able to have a good workflow in the photogrammetry processing. Yeah, I just put a little bit of sketch of like what my my pilot was drawing about all the lever arms, so that like from the IMU, how far is the camera, how far is the GPS antenna, and we had to do all the let's say manual adjustment, so that certain things, for example, the roll and pitch were coming from the IMU, the yaw was coming from the differential GPS or let's say the 2 antenna GPS system heading. But of course, underneath the bridge, you have to fill the gaps, and also sometimes you know that you are on a boat, so the water level will not change. So if we have a float solution in GPS, we just corrected those small shortages with kind of manually filling the holes in the Z position. And yeah, very, very interesting is we have lots of photos, but we have also gaps in the photos. So there's no kind of systematic way to manually match the photos, the IMU, and the GPS here. So what you see here is really the number of pictures and the trigger events. So you have to manually adjust all these data flows, which sound like it's not a very well developed solution, but because we have only 2 weeks to prepare the boat and go there, because of the situation that like it's just arised, we could go there. And yeah, what is very important here is it turns out that if you just put all your pictures, like it was like from one boat ride, it was 1,500 pictures. So overall, we have 3,000 pictures from the boat. If you just put all of them into the photogrammetry processing software, if you fill it garbage comes out. So you really have to be careful that, for example, the left side and the right side of the bridge is very similar. So you need really precise, accurate location and orientation. And at the end of the day, what we found out is if you have overlapping picture from the boat and the drone, then you want to merge everything in a common processing workflow. And what would be even nicer if we would also use in the photogrammetry process the LiDAR, let's say, solution. And I don't know if TerraSolid can already do it, but we were kind of hoping that there is some software in which you just threw everything in and then it could do a nice job. So just to give you a little let's say, insight, the boat was actually driven manually around the bridge. So you see here the boat's pictures. You see one drone flight, and then you see all these circular patterns. So there are certain points which were marked on 165 pictures just to have good manual tie point adjustments. And at the end of the day, you have a kind of a good point cloud of the bridge itself. Of course, we are here in a LiDAR conference, so we also sampled airborne LiDAR and also terrestrial LiDAR scans. And as I mentioned already, we also have the bathymetry multi-beam survey. So you wanted to put everything together, everything has to be consistent, same coordinate system, and then you could start making your model. So just for curiosity, what do you guess which survey is this? Of course, we are here, so this is the airborne LiDAR scan. This is probably easy. This is from the bathymetry, right? What about this? This is from the laser scanner on board the boat. So you see that like under part or the higher parts of the bridge are not visible, but the two shores are very nice. Whoever works in photogrammetry will know that if you see this was from the photogrammetry itself. And then, because you don't see the underside of the bridge, this is from the terrestrial scan. So if you put everything together, then you have this large point cloud, including all different data sources. And then, if you collected all your data, or even during data collection, you want to do quality checks. So point density in each part, coverage, have you surveyed everything? You also want to see what is your absolute accuracy. So there were like land surveyor marks on the bridge. We measured the distance from those, and also see different cross sections, how consistent your data. And these are coming from the data processing team. So for example, the TLS scan, we know it's more precise, more features. So if you want to have these really detailed ornaments, then you can only extract it from here. But a lot of things are obstructed, and there's very high amount of data. So sometimes you are not have enough computational power to really use those. Bathymetry is the only way to get the bottom of the river. And it's also very important that, like, for example, to have the crane which is working on the bridge, you really need a good, consistent data between the bathymetry and the banks of the river. So you really have to make sure that the two data are continuous and looks nice. And of course, the big advantages of aerial scan. It contains the most amount of surfaces, and many things can be only evaluated from this one. And it's also very good in a sense that it gives you a general overview. So if there's a data processing team working remotely who have never seen the bridge, this would be the first thing to give them so that they are able to look and see where they want to start, how they want to kind of intersect or dissect the project. Of course, we know it's less precise, and some of the tools which are built in certain software are more tailored for TLS scans. But the team was saying that, like, many times what they extracted from TLS, it was projected back into the aerial scan because that's a more consistent picture of the whole bridge. Then, after we did the quality check, we do the data pre-processing. We also have to get all the data in the right format, in the right software tools, and also make sure that we are not having too large sub-projects. So decimation and tiling. And then next step, what we were doing is vector feature extraction. So there are nice tools, for example, Topodot, in which you are able to put the photogrammetry and the LiDAR together and extract all the interesting features. And there are templates in it. But of course, in a bridge like this, templates have to be developed for the project. So usually templates do not work for like generic templates. So then we did, based on Topodot, we did the vector database creation. So you see all these guiding lines, what we extracted from the survey itself. It's also a very crucial step for preparation for the 3D modeling. You draw all the lines which are guiding you in the process. And of course, you have to use a clever combination of TLS and ILS and probably augment it with the photogrammetry so that you have a good situational awareness of what you are actually modeling. Then certain things cannot be really vectorized, so we had to create meshes for certain parts. And yeah, for example, the lines on the four ends of the bridge, it would be pretty difficult to vectorize. So we made actually some cheat to use these, just make one line and then mirror and rotate them. And of course, to get a good representation of the river bottom, you also need a mesh. And then after that, we went to Revit. So I know it sounds complicated, that like all these different steps. This was kind of the most intuitive for us because we had experience with all these tools, and probably there's no one single solution to do it. So in Revit, we actually created these families of models which can be copied, can be put into different places of the project, can add attributes to it. And then based on these Revit workflow, we were able to dissect the project, so different people working in parallel on it, and also using these previously extracted vector features, we were able to guide through the entire 3D model to extract 3D models. And For the complex structures, we use these meshes, and we use BIM 360 to kind of glue together the workflow, so for the teamwork. And we used Cloud Compare for kind of like, and quality check. So what you see here is really like, what are these families in Revit? So we made one of these lampposts, and then we use the same lamppost for different locations. In the video, you have seen also some of these large stones or kind of like statues. And then, of course, it's very important if you have a large project, many people working together, have consistent kind of communication between team members. So marks and issues in BIM 360 are, I think, must have if you have a larger project. So just in summary, we have data capture with different sources. We have different software tools with which we actually post-process the data and put it together into a consistent kind of picture based on which the team who was doing the vector feature extraction started working. We had kind of 3 days on the field to do the survey, plus we did a trial run in another bridge somewhere else where it's easier to get access. And then for the data processing, we got 10 days. Because, as I explained, there were a lot of these custom-made data processing steps. And for the vector feature extraction and 3D modeling, we used Topodot, Cloud Compare, Revit, BIM 360, and it was like 153 hours of total estimated time, and roughly 110 hours for the pure modeling, which is kind of an underestimate because a lot of people were using their holidays to just work on the project because they really like the bridge and the project itself. So just as a conclusion, what we got from the customer, so they were saying that like, oh, if they would know that such thing exists and how to use it, then they would have already ordered it before the whole bidding phase, so that like they could not just only plan how much one of these stones would weigh and design the crane to handle it, but also it would be a much better thing to estimate all the required effort and amounts of work to do, and also during construction, if you already built up such a model, then you would be able to use it in the construction phase. I know it's common practice to use BIM in let's say building, but less in linear infrastructure. So we are trying to educate our customers that it is also a feasible solution to do it also in linear surveys. And with that, I would like to thank you, and I hope next year I'm going to be able to talk about some more exciting projects what we are working on, namely hydrogen-powered drones. Thank you very much.
Thank you.